20. Yeah, so we're going to turn past page 20, turn past page 21. Again, this is going to be done in class tomorrow, so you'll get directions on that. And then we're going to go over to page 22. Now, this is what we're going to do. This whole page right here, and that's it. In order to do this page, I have written a big box, and then I've split it into 4. I'm going to show you, I don't want to uncover this yet because some of this we're about to do. I'm going to show you what this should look like. So if you want to pause the video when you see this next screen, you're going to draw that table, this right here. See, this is on page 20. You're basically going to copy this onto page 22. So go ahead if you need to pause this, take this whole thing, and then I told you in class to use a piece of graph paper, so if you want to cut out a little piece of graph paper, then you won't have to draw all these little lines. Okay, go ahead and draw this onto page 22. All right, now we're heading back to page 22. Let's read this and mark the text. So we're going to pay attention to the years and the money as we talk about Sally's savings account. Sally's aunt put money in a savings account for her on the day Sally was born. The savings account pays interest for keeping her money in the bank. The ratios below represent the number of years to the amount of money in the savings account. So that's really important that we just kind of picked out what are the two things being compared. After 1 year, the interest accumulated and the total was 312. After 3 years, the total was 340. After 6 years, the total was 380. So hopefully you're noticing that as the years go up, the money's going up. After 9 years, the total was 430. And after 12 years, the total was 480. Our job right now is to determine, is this a proportional relationship? So is the number of years proportional to the amount of money? So what you're going to do is you're going to take this and put it in your own words in the problem. So really this important stuff that we mark the text, we're going to put it here in the problem. So this is called the fourfold method. We're going to be using it right now, and then we're going to be using it in class tomorrow. We're going to first write the problem, then make a table, then a graph. Using all those things, then we'll say whether it's proportional or not. And you should feel like an expert in that by now, being able to determine if it's proportional or not. All right, here's the problem in our own words. After 1 year, the total was 312. After 3 years, 340. 6 years, $380. After 9 years, $430. And after 12 years, $480. So I already typed that out. You can pause it. If you like putting it in your own words, go for it. But this is kind of a paraphrase of that if you'd like to copy it down when you pause it. Okay, moving on to the table. So you know that the table is going to be sort of an XY. Well, the years are what determines the total. So the years has to be our X, and the total amount has to be our Y. Now, how are we going to figure out how much money that goes with each year? Sorry, so after 1 year, I can see that the amount was 312. Now, I already put the little dollar sign there, so that's why I can just put 312 without a label. Okay, then it doesn't tell me after 2 years, but it does say for 3 years, it's 340, and so on and so forth. So go ahead, pause it, and try filling it in on your own, then unpause it and see if you have it right. So after 6 years, it's 380. After 9 years, 430. After 12 years, 480. How did you do? Hopefully it was pretty easy to fill in the table. The hard part here is going to be the graph, because if you're noticing, these numbers are pretty large. Let's go ahead and put our labels on here. Let's call this Sally's savings account. And we can see, oops, U-N-O-U-N-T. Okay, we can see that the years is the X, so that's going across. And those numbers are 1, 3, 6, 9, and 12. So I could probably do 1 year per number on the number line. However, the total amount, the Y, total amount, we want to put a dollar sign, so we know it's just dollars. Some graphs will say like millions of dollars or tens of thousands, things like that. This is just regular dollars, so $312, not thousands or millions. So go ahead and put that there on the y-axis. But I can tell I'm not going to be starting 0, 1, 2, 3, 4, 5. I mean, we're never going to be able to put $312. It would go way too high. So what we need to do here is determine what should our labels be. For the years, let's just go ahead and start 0, 1, 2. Label each one of those. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And at least on mine, you can see that it kind of gets bold at the 5, 10. And then here we can go to 15, which is good because the years end at 12. So I will be able to fit all my years in. So the point is, for here, for going up, we need something from 0 to at least $480. What could we go up by here? Could we go up by $5, 10, 20, 30, 40, 100, 150? If we go by 100, that might be a real tiny chart because then it would just go up here to about $500. Let's go up by 50s. I think that would be good. So every 2 lines, write the number 100, and then go 2 more and write 200, and then go 2 more and write 300. Well, you know, that kind of that's pretty short. Hopefully if you have a pencil, what do you think might be better? What should we go up by here? Maybe if every other line is 50. So let's do that. Every other line is 50. So we can't squeeze all these little numbers in there, but that would be like about 25. So go up to and then go to 100. So this would be 100. This would be 50. Okay, that might work a lot better. So let's go here and do 150 and 200. So that's okay. Sometimes you do need to figure out what the best one is. So that's 250. Let's keep doing that. Let's keep going up by 50s. Every other line. 350, 400. And if it's getting squeezed in there, just pay attention to how I'm doing this. I'm going every other line. Oh wow, this is going to work out really nice because that takes me up to 550, 50, 10, 150, 200, 250, 3, 350, 4, 455, 550. Okay, good. Pause it if you need time for that. Otherwise, let's continue on with our graphing. So after 1 year, I have $312. Now, this is not going to be exactly on $312, but I do know that it's going to be somewhere in between 300 and 350, or even in between 300 and 325. So that's okay. It might be hard to get right in there. Mine, especially with this marker. Hopefully with your pencil, you can make a real specific point. Okay, for 3 years, we're looking for $340, so that one can be a little closer to the $350 mark. Okay, now go to 6 years. That's right here. And then for 6 years, we're looking for $380. So that's going to be between the 350 and the 400 over here at 6 years. So that's where I'm going to put my next dot. 6 years, 380. Okay, why don't you pause it and try the 9 years and 12 years by yourself and then see how you did. There's 9 and 12. Okay, there we go. There are our red dots, and hopefully you can see right now, does it make a straight line? It looks pretty straight. What else has to be true, though, in order for it to be proportional? Hopefully you're thinking back to lesson 5 when it said it has to pass through the origin. So did it pass through the origin and make a straight line? No, because even if it did start at 0, 0 and go up to 1 year, 312, that's not proportional because that's definitely not going to make a straight line along with the rest of it. So go ahead and now tell me, is it proportional or not? And the answer is no. There's no constant multiplier in the table. 1 times 312 gives me 312. And then how do you get from 3 to 340? You can easily divide and figure out that that's not going to be 312. You can use, your common math sense to realize that it's going to be about 100 or a little more than 100. So this one is times 113.3, repeating right there, no constant multiplier. Okay? So there you go. That was as easy as that was. That took us less than 10 minutes to complete the entire problem, and that was with directions. So tomorrow in class, it should take you, maybe about 10 to 15 minutes because you'll be working together as a group, and you're going to have something similar to this. Now, not every example tomorrow is going to be non-proportional. Some might be proportional, some aren't. In order to be proportional, it's got to be a straight line through 0, 0, and there has to be a constant multiplier. Okay, if one of those things doesn't work out right, then you can say that it's not proportional and then prove it. We're working really hard lately on the explanation. Can you prove to someone why it's not proportional? Okay, so that is your lesson 6 video. Hopefully you're appreciating. That's the shortest one so far. So let's stop this before we get to 11 minutes, and I will see you tomorrow.